Alright, hello, my name is Gabriel Fong and welcome back to another math tutorial video. Today I'll be tackling two questions from the Nanyang JC H2 Math tutorial package for applications of differentiation. Okay, so this video is dedicated to Elena and all my friends who are going to watch this video. So the main reason why I want to tackle these two questions is because I couldn't do them when I was doing this tutorial as a further math student, and if I can't do it, you guys probably can't do it. Not as an insult, as a if I like, you get my point. I'm not just saying it as an insult, but let's get right to it. Anyways, my whiteboard is on what is it, ironing board, because the hooks have spoiled and I need to get them replaced. So you're gonna see my butt a lot in this video. Yeah. Okay, let's get started. Alright, so let's start with question 9. A right circular cone with radius 3 cm and height 9 cm is initially full of water. Water is leaking from the circular base of the cone at a constant rate of 2 cm cubed per second. Find the exact rate of change of the depth of water when the depth of water is 6 cm. Okay, so let's start off with the information that we've got. The first information we've got is that it's a right circular cone. So let's draw a model of a cone. Alright, so this is a cone. And the height of the cone is 9 cm, while the radius is 3 cm. So this cone is initially full of water. So let's do some simple math. Alright, so the volume of cone, alright, is 1/3 pi r squared, pi r squared height, which is 1/3 pi 9, which is 81/3, 27 pi cm cubed. Alright, with this out of the way, we have another piece of information that water is leaking from the circular base of the cone, which means that it is trickling out from here at a constant rate of 2 cm cubed per second. So the second information is that dV dt, the change in volume with respect to the change in time, is negative 2 cm cubed per second. Okay, so now, whenever I do this type of questions, I always tell myself, thought process. So my thought process is telling me this, that this is probably a related rates question. I'm going to do some screwed up dy dx chain rule stuff to get what I want. Which brings me to my last point. What do we want? Let's have the depth of water, alright, be x. Okay? So we want dx dt. So to start off, dv dx times dx dt equals dv dt. Alright? Which means that my working should be making me work towards what dv dx is. That is the thought process that I am following. And this is generally how you should tackle every math problem, by writing out the information you have and processing said information. Alright, with that out of the way, we want to work towards dv dx. Alright, so now let's illustrate this in our diagram. This will be x. So I want you to notice something. When you split the cone, since it's a right cone, you can split it like this. When you split it like this, you form another smaller cone. And this small cone has a height of 9 minus x cm. What do you think of when you see two different objects with similar dimensions? For me, I would think of this thing called similar figures. So by similar figures, it states that the ratio between the smaller height over the bigger height, both of them cubed, is such that it's equal to the volume of the small cone, alright, over the volume of the big cone, which as we have found is 27 pi. So we can do some simple math such that the volume of the small cone equals to 27 pi 9 minus x cubed over 3 power 6. This is 3 power 3, so it will be pi over 27 of 9 minus x cubed. So now we have v and x. So now, taking first derivative with respect to x on both sides. Alright, we will have dv dx equals to, you bring the 3 down, 3 over 27 pi 9 minus x. Hey, sorry, I missed out a crucial step. Before we take the first derivative with respect to x on both sides, please realize this. The depth of water is x. Alright? Since the depth of water is x, it means that you see the frustum, which is basically this big shape, you have a cone and the water is leaking down such that it forms a frustum. So you don't want the volume of the small cone, this is where I'm wrong. You want the volume of the frustum. Alright? Which is equal to 27 pi minus pi over 27, 9 minus x cubed. So now, taking first derivative with respect to x on both sides, we get plus 3 over 27 pi 9 minus x squared, which simplifies to 1 over 9 pi 9 minus x squared. And now, let's plug it into our formula. Dx dt equals to dv dt divided by dv dx, which is equal to negative 2 divided by pi over 9 minus x squared. But as we established that the depth is x, and they want it such that x is 6, so we just sub 6 into here, such that negative 2 divided by pi over 9, 3 squared equals to pi 2, negative 2 over pi, which is the answer. Woo! Guys, look at how short the working is. If you don't understand, just do some Moody Blues and backtrack a bit, and yeah, you can rewatch it. On to the next question. Please write units. Yeah, please write units. On to the next question. Woo! I am so sorry that you have to see my bum and waste your time watching me wipe the board. This is why I have timestamps in the description of my videos. Alright, with the board somewhat clear. On to question 10. So now we have this cute triangle over here, which is, so we have this thing, x, this other thing, 8, we have this thing, the wall, yeah, D, you have a point E over here, alright, and then we have the points A, B, C. Okay, so consider this. They want the shortest straight beam, i.e. AB, which means they want the shortest length that AB can be. So looking at this diagram, you want AB, okay? So what do? if you want AB, you should solve for AB in terms of information that you have given. Alright? So now let's revisit the concept that we just discussed in the previous question. And what is the concept? Similar figures. In this case, instead of having a 3-dimensional similar figure, we are using the first dimensions. Not first dimension. Is it first dimension? Yeah, we're using the first dimensions version of similar figures, i.e., length. Okay. So now, oops, my brain kind of farted. Now I know why. Okay, this is 3. So now, by sim figures, let's go. The short height over wall equals to the short length over the long length. So by doing simple math, wall equals to 3 plus 8 over x. Pretty sure it's correct. So let's simplify it a bit. Equals to 3 plus 24 over x. This should be 8, this should be x. Alright, so now we have the height of the wall. So what are we going to do with this wall? Well, this is a right angle triangle. What's one of the most powerful things about a right angle triangle? Pythagoras theorem. I hope you know that. If not, please go back to secondary school and do your E-math papers. So by Pythagoras theorem, alright, wall squared plus AC squared equals to AB squared. Alright, settled, let's go. So wall 3 plus 24 over x squared plus AC, which is x plus 8 squared, equals to AB squared. Alright, so let's expand this together. 24 plus 9 plus 6 times 24 x, because if you do your cross multiplication, plus 24 cubed over x squared, alright, plus x squared plus 16x plus 54 equals to AB squared. I trust that you're smart enough to simplify it all by yourself. And if I'm wrong with the algebra, I'm sorry, I will go back to secondary school. Okay, so now the question is, should you simplify or not simplify? The beauty about JC math is that typically what you learn builds from things that you've already learned on. So you should have learned this in your first differentiation lecture. You learn how to do implicit differentiation. So I want you to compare two things. Imagine you taking square root of AB and this huge monster, alright? Versus you like doing implicit differentiation. Which one will be more palatable to do? Obviously obviously doing implicit differentiation is nicer to do because you end up with a nice looking thing that can be simplified into something redacted, which I will share with you later. While let me explain to you why right now. So now, taking derivative with respect to x on both sides, you get negative 6 times 24 over x squared minus 2 times 24 squared over x cubed plus 2x plus 16 equals to 2ab. Alright, 2ab dA dx. Alright, so they want minimum point. And what does minimum point entail? Minimum point entails that dAb over dx is equal to 0. So since this is equal to 0, it means that this is also equal to 0. So crisscross, this is gone, haha. And now, assuming that x is not 0, you can do some cross multiplication such that you have negative 6 times 24 x minus 2 times 24 cubed x plus 0, plus 2 power 4 plus 16 power 3 equals to 0. Now, plug it into your GC, and I'm going to use my GC to check that my working is correct right now. Okay, so my 216, is that 144? 216, negative 6 times 24, that is not negative 144, minus 224 cube. Oh no, I messed up somewhere. That is not 24 cube, it's 24 squared. My handwriting is terrible, please work on your handwriting. Alright, so now let's plug this bad boy in to our GC. Alright, the x values that you're going to get, alright, include 3 negative numbers and 1 positive number. So please don't be lazy like me and only write out the positive. You have to write out all 4 roots and reject them manually, because you establish that x is a length and length has a positive magnitude. So please reject other solutions accordingly. And one last thing, even though you know that this is the only sensible solution, when you plug back into your wall equation, which is this, even though you know it's the only sensible thing, right, you still have to do either your first derivative test or your second derivative test to prove that it's a minimum point. And x equals to 4.16 is the answer. You will get your wall to be 15 after you do your basic calculations. That's about it. So I'm sorry if I'm talking a bit fast today, because my brother is playing games behind me and I don't want to distract him. I want him to enjoy his time. If you like the video, please share it with your friends, because I would appreciate if more people watch my stuff. Yeah, if you have any requests, just drop a comment on the videos I make, and I'll try to get back to you as much as possible. Bye!